Okay, so I provided this worksheet here. You can print it out. I made a copy for you so you can take notes with me here and you don't have to draw this all out. If you don't have a printer, well then unfortunately you are going to have to draw this out, draw the instructions, okay? So if you have to pause it, right? If you need to draw or whatever you need to do. Okay, so this is what you're going to see. You're going to see an external point out here with two tangent lines. And then sometimes you're going to add these extra lines. Like this one just has the tangent lines and then actually these radii, right? Anything from the edge of the circle to the center is a radius. But sometimes you'll put extra lines and then it starts looking confusing. But this is what I need you to ignore. And just look at the tangent lines, these. And from the previous notes, from this point, this is a tangent line, and this is a tangent line. And yes, we know it makes 90 degrees with the if you put a line to, but we don't need that right now. Yes, it is true that this makes 90 degrees, but we don't need that right now. All we know is, all we got to concern ourselves with these first problems is, if you have a tangent line from that share a common external point, one going here being tangent here and another one being tangent here, then what did we know about these two segments? That they're congruent. That this segment is going to be congruent to this segment. And that's why the math is easy, right? It says solve for x. Assume that lines which appear to be tangent are tangent. Well, they do look tangent to me. So this is what you have. If you have an external point with one tangent line, and from that same point you have another tangent line, then these two parts are congruent. And what do we know in geometry? What do we do with congruent parts? We set them equal to each other. So we're going to have 12x equal to 11x plus 2. I don't care about this line here. I don't care about this line. They're not asking me this. Honestly, this is a radius, right? From the center to anywhere, from the center to any edge of this, right? A straight line from the center is a radius. And if this is 14.7, well, I know this is 14.7 too, right? Because all the radius are going to be the same. But we're not concerned about radius. I'm just looking at the tangent lines. And if they're drawn from an external point, a common external point, then all you got to do is just know that this is congruent to this. And when you put those congruent to each other, they're equal to each other, right? And when you solve for this, you're going to get x equals 2. And that's what it says, solve for x. So let's see, if this is x equals 2, that's 12 times 2, that makes this one 24. And 11 times what? 2 is 22 plus 2, it's also 24. See, it's going to be congruent. Don't worry about these other lines. You just got to focus on your external point, which is here, and which are your two tangent lines. This one, the one from here, tangent to the circle, and the one from here, tangent to the circle. Don't worry about anything else. Don't let that throw you off. They're going to draw an extra line, or they're going to draw these lines like this, right? The radius. Later, yes, we'll look at that 90 degrees. But right now, for these problems, what is true about these two tangent lines that are coming from this, that share a common external point? They're congruent. So as far as math is concerned, these are congruent. So what do we do with congruent parts? 4x plus 5 equal to 3x plus 15. And then you solve for x. So that's going to be 4x plus 5 equals 3x plus 15 minus 3x minus 3x. That's going to be x plus 5 equals 15. Then minus 5 minus 5. That's going to be x equals 10. So that's what you know about these tangent lines that share an external point. they're congruent. Let's see, 10, if x is 10, 4 times 10 is 40 plus 5, this is 45. And obviously 3 times 10 is 30, 30 plus 15, 45. See, they're gonna be congruent. And again, this one, they drew like a little line in the middle. I'm not looking at that. Don't let all these other lines and this thing that looks like a triangle here throw you off. You just look at your external point and your tangent lines. Your tangent lines are the one that's tangent to the circle there and tangent to the circle there. Don't worry about anything else. You just look at that. And for the geometry of this, what's true? Well, these are going to be congruent. Okay, so what do we do with these congruent parts? We set them equal to each other. 19x minus 2 is congruent to, so they're equal to each other, is equal to 18x. And here, I'll move the negative 2 over there, makes it positive. I move this over here, makes it negative, so it's going to be 19x minus 18x equals positive 2. I'm going to get x equals 2. I got 2 of them that have x equals 2. Well, that's not always going to be true. Okay, so there it is. As far as math goes, that's easy, right? Okay, now it's going to get like super, all of a sudden a little bit more complicated. Okay, and that's what you're going to see in the next video, okay? But these first type of problems, if you got tangent lines that share a common external point, they're tangent to the circle, these are congruent to each other. So you set them equal to each other and you solve it. All right? Easy work. Okay, now watch the second video for the second part of the problems. Are totally, well, not totally different, but different type.